Alright folks, let's look at the KC calculation, the equilibrium constant calculation. I'm going to look at the basic one. A mixture of 5 mole of hydrogen gas and 6 mole of iodine gas is placed in a sealed container of 2 dm3, which is cubic decimeter, at a temperature of 458 Kelvin. The balance equation for this reaction is as follows. We are given the number of moles of hydrogen and iodine to produce that. But now, since they are placed in a sealed container, like that, it's a sealed container. So what is there? It's the hydrogen, and there initially, those are the initial, and iodine. There, it's 6 mole of that and 5 mole of that. Guys, these are the initial amount. These are the initials. These are the amounts before they react, right? These are the amounts before they react. So in this container, so the volume of this container, it's 2 dm3. So it's in the standard international units, right? Now it says in equilibrium, in a certain time frame. At equilibrium is reached in a certain time frame. At equilibrium, there's 4 mole of hydrogen iodide in the container. After these two reacted, right, there's a portion that is taken from this, and this portion, and the portion that is taken from that. So they completely reacted. When the reaction is complete, by saying at equilibrium there's 4 mole, that means there's when the reaction is complete, so 4 mole of hydrogen iodide in the container. So that's the product. So that is what is produced. Now it says calculate the concentration of hydrogen and iodine at equilibrium. At equilibrium, their concentration. So guys, what are we given initially there? We are given, guys, in this table, right, you start with the ratio, which is the ratio, it's 1:1 produces 2, right? And then we have the initial quantity. The initial quantity is this one. It's 5 mole and 6 mole. These are the initials. So we're going to substitute those initials there. It's 5 and 6. Initially we had no product, right? And then when we get to a change here, the change from what we had, this change is amount that is used. Amount used. This is the amount used. So how much were used out of these amounts we have, and how much product was formed? So there, what are we going to do? Since these two are reactants, right? In the reactants, you put the minus. It's going to be minus what? Since there's a 1 there, you say minus 1x, and there's a 1 there and it's a reactant, you say minus 1x. I'll explain it to you why. And then in the product, you say plus, and then plus what? Plus 2x. So we're looking for those amounts there. Those are the amounts are used. These are the amounts used, and this is the amount produced. So amount that is used is going to be a minus. Amount produced is going to be a plus. And then it's 2, and then it's 1, and it's 1 there. Okay, so what are we going to do now? We're told at equilibrium the amount that was produced of hydrogen iodide, it's 4 moles. So let's put the hydrogen iodide. The hydrogen iodide, it's 4 mole at equilibrium. So guys, here, this is the number of moles at equilibrium. So this is what was there initially, and this is what is used, and this is what remains. So at equilibrium, it's what remains in terms of reactants, right? In terms of reactants, it's what remains. In terms of product, it's what is produced. Same quantity that was produced here is the same amount at equilibrium. So we're going to put the 4 there, right? So this 4 is going to help us. What we usually do, we usually say this 0 plus 2x is equal to that. Even though I said that this amount is going to be the same amount there. So let me prove it to you. So you say 0 plus 2x is equal to 4. So which means 2x is equal to 4. So it proves what I just said. So 2x is equal to what? 4. So it proves that at this amount they are always the same, right? So now having 2x is equal to 4, we are looking for x here and x here. So we can simply say we divide by 2 there. We can simply divide by 2 and then our x is what? 2. So that means here we have what? Negative 2. Since it's negative there, so it will be negative 2 and here it will be negative 2. I hope that makes sense. Now we have 2 and 2 there. Alternatively, what you can do there, you can say since now you're only having 4 and you don't have this one and you don't have this one. Let's say we did not calculate it this way. So what are we going to do? We're going to do the mole ratio. Iodine is to hydrogen iodide. The ratio there is I have this amount but I'm looking for this one and this one. So I'm going to do the mole ratio between this and this. So it's going to be 4 is to no. So we put to the ratio. The ratio there is 2 is to 1. So it's going to be 2 is to 1. And then we put x where? In the iodine, you were looking for iodine. We have the hydrogen iodide, it's 4. And then when we cross multiply there, it's going to be 2x is equal to 4. And then we're looking for iodine. And iodine is what? Is x. Let's say we do not have that. So it's going to be x. X is going to be what? 2. So we got the 2 there. And then same thing here, same thing. If you do the mole ratio of hydrogen iodide with hydrogen, the ratio it's going to be 2 is to 1. And then you put the 4 and then you put the x there. And then when you cross multiply, it's going to be the same thing. But with the difference here, it's going to be what? Hydrogen there. So you get the same thing. Now let's go back to the table and proceed. So now this is the amount that remains at equilibrium in terms of moles here. So what we do, we'll say 5 minus 2 is equal to 3 here. So we'll say 5 minus 2 is equal to 3. So what is remained from initially what was there, what is used, and what remains. So what was there initially and what is used, and this will remain. So 5 minus 2 is equal to 3. So even here in this, so it will be 6 minus 2 is equal to 4. And then here, this amount that remained, you converted to the next step into concentration. So we know the formula for concentration. It's number of moles divided by volume, and the volume, it's the initial volume. It's the volume there, which is the 2 dm3. The container was 2 dm3 cubic decimeter. So we'll say 5, and no, not 5. The answer there is 3. 3 divided by 2 is equal to 1.5. And then here we'll say 4 divided by 2 is equal to 2, right? So that's the answer there. And then we'll say 4 divided by 2 is equal to 2. And then calculating the Kc, we'll say Kc is equal to product, concentration of product, which is hydrogen iodide, to the power 2. There's it there. And then divide by the hydrogen gas to the power 1 times by the iodine to the power 1. And then the product there, it's 2 to the power 2, which is this. and then we divide by hydrogen. It's 1.5 times 1.5 times what? 2 there. So if you punch that in the calculator, it's going to be 1.3. That's a KC calculation there. Cheers, bye.